So carbon compound. So type of carbon compound. So actually what is carbon compound? Take out your highlighter or take out your red pen. Boleh highlight mana point-point yang penting dekat sini. So carbon compound. What are carbon compound? Carbon compounds are compound that contains the carbon element. Mana-mana compound yang ada compound dalam dia, so kita panggil dia sebagai carbon compound. So how many groups can be carbon compound be classified? Okay, kita boleh classify dia antara organic and inorganic. So now kita tengok what is organic carbon compound. So organic carbon compound are compounds originating from living things. So we get this one from living things. Contohnya animals or plant that contain carbon atom covalently bonded. What is covalently bonded? Kamu dah belajar masa form 4. What is covalently bonded? Apa maksud covalent bond? Based daripada perkataan covalent bond. So what is covalent bond actually? Anyone can respond? Covalent bond. Covalent bond ni apa? Irvina, what is covalent bond, Irvina? Oh, very good, Zindi. Okay, very good, Iman. Alright, very good. Non-metal bond with non-metal. So, contoh yang ini, carbon bond with hydrogen, oxygen, or nitrogen, phosphorus, or halogen. Okay, examples of organic compounds such as sugar, starch, protein, vitamin, enzyme. So cikgu ambil contoh paling senang because you all budak biology kan, kita ambil glucose. What is the formula for glucose? Dah belajar kan? What is the formula for glucose? What is the chemical formula for glucose? Very good, Jazwan. C6H12O6. So kalau kamu tengok C6H12O6 ni, dia ada gabungan antara carbon, hydrogen and oxygen. Ini adalah contoh organic carbon compound. Okay, now what is inorganic compound? So inorganic compound are carbon compound, means that that compound also contain carbon but do not contain carbon-carbon bond. Dia tak ada carbon dengan carbon bond. Contoh carbon dioxide. Carbon dioxide antara C dengan ya, Ichuan, cepat Ichuan. Sempat lagi. Alright, contohnya carbon dioxide. Carbon dioxide antara C dengan O. Carbon monoxide between C and O. And calcium carbonate adalah antara C with calcium and oxygen. Tapi kalau organic, dia mesti ada carbon to carbon. Contoh glucose structure C ada 6 kan? 2, 3, 4, 5, 6. So you nampak dia ada bond between carbon with carbon. So bond yang ada ni is covalent bond. Ini baru we call as organic carbon compound. Ada bond between carbon and carbon. Alright, kalau inorganic, they don't have carbon-carbon bond. Okay, now kita pergi kepada seterusnya. Okay, now how to classify carbon compound? Okay, organic compound. How to classify organic compound? Dia tertinggal dekat sini. Organic compound ni, case yang ini, kita boleh classify dia into 2 groups. Okay, tadi carbon compound 2, organic dengan inorganic. Organic compound pula, we can classify into hydrocarbon and non-hydrocarbon. So now, look what is the differences between hydrocarbon and non-hydrocarbon. So hydrocarbon, what is hydrocarbon? Hydrocarbons are organic compound that contain only, alright, the keywords here are only carbon and hydrogen. Kalau dia ada carbon and hydrogen sahaja, itu kita panggil sebagai hydrocarbon. Contohnya petrol, carbon dengan hydrogen. Natural gas pun sama, carbon dengan hydrogen. The easiest examples is gas dekat rumah kita tu, dalam tong gas ni untuk memasak tu. Apa nama chemical dia? Siapa tahu? What is the chemical name for gas yang kita guna untuk cooking tu yang kat rumah tu, dalam tong tu? Apa nama chemical name dia? What is the chemical name for gas yang kamu guna untuk masak? Siapa yang dah tuition mungkin dah belajar lebih daripada ni. So apa nama dia? Kita share dekat sini. Untuk yang tak tahu lagi. Apa nama? What is the chemical name? Cepat, siapa boleh jawab? Apa chemical name untuk gas dekat rumah yang kita guna untuk masak? Jazwan? Hui En, apa nama gas tu? Google say LPG. Okay, dia ada nama kimia dia. LPG tu nama dia liquid pressure gas. Dia ada nama chemical dia. Apa nama dia? LPG tu betul lah, tapi itu bukan nama kimia tu. Tu panggilan dia. Dia ada nama kimia dia. Chemical name dia. Start dengan B. Cikgu bagi clue. Start with B. Siapa dah belajar tuition? Mana orang-orang yang pergi tuition? Pandai NG, butane. Very good. So, butane is chemical name for LPG tadi tu lah. So, butane is one examples of organic hydrocarbon yang kita guna kat rumah selalu. NG, sambung. Apa formula butane? Dah belajar kan NG kat tuition? What is the formula for butane? C? Nak tengok NG boleh jawab tak? C? Gelak pula dia. Berapa? C berapa? Butane. Yang lain senyap je, semua tak nak ngaku pergi tuition. Cepat, berapa? C berapa? C? Oh, pandai. Yes, terbukti. Tak sia-sia pergi tuition. C for H10. Perfect. Pandai. Alright. So, this one is examples of organic hydrocarbon. Butane. So, what is non-hydrocarbon? Okay, apa pula non-hydrocarbon? Non-hydrocarbon organic compound, dia contain carbon, hydrogen plus other element. Kalau tadi ni C and H sahaja for hydrocarbon, for non dia ada C and H wajib, plus dia tambahlah mungkin ada oksigen, ada nitrogen, plus phosphorus, plus halogen tu Cl ke Br2. Ini contoh non-hydrocarbon. Okay, contohnya protein. Protein, starch dengan alkohol. Ataupun tadi contoh kita ambil glukos. Glukos tadi apa? C6H12O6. Nampak ada O, ada H, ada C. So this one is non-hydrocarbon organic compound. Alright, boleh beza ya boleh beza ya hydrocarbon and non-hydrocarbon? Okay, boleh ya? Kalau boleh beza, then I proceed to the next one. Boleh? Sebab dalam topik ni kamu akan belajar dua-dua. You akan belajar hydrocarbon and also non-hydrocarbon. Alright, kita pergi seterusnya. Okay, hydrocarbon pula. Ada berapa group? Okay, hydrocarbon. Ingat, hydrocarbon ni hanya yang ada C and H. Alright, so kita ada saturated, tepu, and unsaturated, tak tepu. So kita tengok what is the differences. So actually what is saturated? Okay, kita fokus kepada first one, saturated, tepu. Okay, hydrocarbon that contains only berapa? Only single covalent bond between carbon atoms. Single, the keyword here is single. Saturated as hydrocarbon that contain only single covalent bond between carbon atom. So this one is the example. Kamu tengok contoh ni. Between C and C, between carbon and carbon, only single covalent bond between these two C. Sama juga. So ini kita panggil sebagai saturated hydrocarbon. Okay, siapa yang dah belajar tuition? Apa nama ni? Ada C3H8. Apa nama ni? C3, tengok ada H8. Yang tuition apa nama dia? C3H8. Cepat. Oh, pandai NG. Propane. Perfect. Propane. Okay. This one is example of saturated. Okay, now. So, apa pula dia unsaturated? Hydrocarbon that contain at least one double, okay, one double or triple covalent bond between carbon atom. Okay, this one is the example. Double covalent bond. Tengok ni. At least dia ada one. Dalam structural formula dia ni, at least ada one double bond. Itu kita dah panggil sebagai unsaturated. Yang this one, at least ada one triple bond. Kalau ada 2, 3 dalam satu baris ni, pun kita dah anggap sebagai unsaturated. As long as dia ada satu sahaja single or triple bond, kita dah assume dia sebagai unsaturated. Sebab kalau saturated, semua adalah single covalent bond. Okay, boleh beza saturated and unsaturated? Alright, kalau boleh beza ya. Elvin, okay? Alright. Kimberly, are you okay? Alright, now kita tengok kepada the main source of hydrocarbon. Mana kita nak dapat hydrocarbon? So the main source of hydrocarbons is petroleum. Macam mana kita, how petroleum is formed? It is formed as a result of decompositions of plants and animals that died millions of years ago. Okay, sebelum kita sambung, kita tengok video ni. Video kanak-kanak tapi nampak menarik. Macam mana petroleum terhasil. Okay.
Where do we get oil from?
Dengar tak? Kalau dengar, cikgu nak sambung pasal. Alright, very good.
The Earth's surface millions of years ago was covered with more water than what it does today. And living in this water were billions of tiny plants and animals. When these plants and animals died, they fell to the ocean floor and piled up. Sand from eroding rocks and mud covered them up. These layers of sand and mud were heavy, and this weight turned them into sedimentary rocks. Heat from the earth and the weight of the rocks caused the dead plants and animals to compress into oil. Once the oil is formed, it slowly moves up through pores in the rocks. However, in some cases, rocks without any pores leave oil trapped underground. Oil is found in different parts of the world. The places where oil is extracted are called oil fields. More than half of the world's oil is produced in the Middle East. To get to the oil, an oil company must first drill down to it. A rig is set up to support the drill. Then a well is drilled into the ground until the oil is reached. If the oil field is in the sea, then offshore rigs are used.
Okay, selesai. Habis. Alright. So, kamu dah tahu dah bagaimana petroleum is formed daripada decompositions of plants, dead plants and animal. So, kalau dekat Malaysia ni cikgu nak tanya lah, usually dekat mana kita jumpa oil field? Kat Malaysia ni kat mana? Which state yang ada oil field? Anyone can share? Very good. Sarawak lagi? Sarawak je? Sarawak lagi? Selain daripada Sarawak ada satu lagi. Terengganu. Pandai je hui Terengganu. Sarawak and Terengganu. So Malaysia ada their own oil field iaitu Sarawak spesifik dekat Miri and Terengganu dekat Kemaman. Spesifik dekat situlah dekat Paka Kemaman. So siapa-siapa yang berminat nak kerja bidang oil and gas, so bolehlah masuk dekat situ. Siapa daripada Sarawak, siapa daripada Terengganu, kamu kena banggalah. Sebab dekat tempat kamu ada. Siapa pernah pergi? Siapa pernah lalu? Terengganu. Angie, you pernah lalu area Kemaman, area Paka? Yes. You pernah lalu? Siapa pernah lalu dekat area proses minyak? Siapa pernah lalu dekat that area? Oh, you kampung NG. So you pernah lalu lah. You pernah lalu that area yang diorang proses minyak tu. Pernah lalu tak NG? Oh, don't know. Ayo, don't know macam mana ni. Kalau kamu lalu, kamu akan nampak 24 jam akan ada api yang keluar daripada tempat pemprosesan petroleum tu. So nanti kalau kamu lepas PKP, kamu ajaklah parents kamu lepas PKP, lepas boleh rentas negeri, ajaklah your parents paling dekat pergilah Terengganu untuk tengok macam mana situasi kilang ataupun tempat proses petroleum. Okay. Leko memang sedap NG, itu for sure lah. Okay, so what is petroleum guys? So actually petroleum, terima kasih Teguh, dekat Kertih, dekat Kemaman pula. Kertih, thank you. Dekat Kertih Terengganu, betul. Sorry, dekat Kertih NG, that's why tak jumpa. Okay. Okay, what is petroleum guys? Okay, petroleum is a mixture of different molecular size of hydrocarbon. Okay, petroleum adalah campuran molekul hydrocarbon yang ada different size. Okay, why does petroleum have to be refined? Kenapa kita kena refine before we can use it? Because petroleum cannot be used before it processed. Kita must separated it into fractions before it can be used through the refining process. Masa kamu lower form kamu dah belajar ke fractional distillation? Masa form 3 atau form 2 tak salah cikgu, dah belajar ke fractional distillations of petroleum? Pernah tengok tak bagaimana proses tu berlaku? Okay, now kita ada a few stages in the oil refining process. First, kita ada fractional distillation, and second we have cracking. So how the mixture of different molecular size in petroleum is separated? Macam mana kita nak pisahkan? Sebab kita ada fraction tau. Nanti cikgu tunjuk gambar contoh macam ni. Okay, ini contoh. Macam mana daripada crude oil ni kita boleh separate dia into a few levels. So mari kita tengok explanation ni dulu. Okay, this hydrocarbon can be separated using fractional distillation of petroleum at different temperature. So the keywords here is different temperature. Different temperature. So different temperature will produce different types of petroleum. So this process kita panggil this process separate into different fraction in the distillation tower. Kita guna the big distillation tower untuk separate the petroleum based on the temperature. So what is mean by fraction? Apa yang dimaksudkan dengan pecahan dalam distillation tower ni? So a fraction is a mixture of hydrocarbon within a particular range of boiling point. Dia depends on the boiling point. Tadi Kak Atta dah cakap kan, based on temperature. In each fraction, the hydrocarbon have similar number carbon atom per molecule and physical properties. Mean each fraction tu kalau kita nak pisahkan dia, usually the bilangan karbon dia lebih kurang sama. Physical properties dia pun lebih kurang sama. So kita boleh letak dia satu tempat. Okay, nah macam mana kita nak pisahkan? Alright, physical properties dulu. Physical properties enable the separation. Okay, pertama different molecular size. Okay, tengok kat sini keyword dia different molecular size have different boiling point. Okay, tadi kita dah tahu dah untuk separate the petroleum based on temperature, based on different boiling point. So different boiling point ni dia akan berkait dengan different molecular size. Okay, hydrocarbon with lower boiling point, okay, boiling point dia lebih rendah, vaporize. So dia akan change become vapor to the top. Kamu dah tahu kan kenapa vapor akan dekat top? Terima kasih Puan.
Sama-sama. Okay, bye-bye.
Okay, bye-bye. Alright, cikgu nak tanya kenapa bila lower boiling point dia vaporize. Kamu dah tahu kan kenapa? Why lower boiling point dia akan vaporize? Sebab apa? Pandai sini. Because less than to the top of the tower before condensing and separated. Manakala if the hydrocarbon to the higher boiling point, dia akan collected at the bottom of the tower and condensed as liquid. So kalau boiling point dia rendah, dia akan at the top and vaporize dalam bentuk gas. And then bila dia dekat bawah, dia akan higher boiling point, dia akan duduk dekat bawah and then dia akan form as a liquid. Alright, now what are two main uses? Apa kegunaan hydrocarbon? Okay, derived from fractional. Pertama as a fuel, tak kisahlah bahan api untuk apa, untuk kereta, untuk lori, untuk kapal, untuk rumah, okay. Dan juga raw material for the petrochemical industry. Okay, so this one is the tower. Inilah tower dia. So tower ni yang dekat atas ni mempunyai boiling point yang macam LPG ni. Boiling point dia adalah lebih lower. Manakala bitumen boiling point dia paling tinggi. So bagaimana proses ini berlaku? Kamu tengok. Pertama dia akan masukkan crude oil dalam this one. And then dia akan heatkan until reach 400 degree Celsius. Bila jadi 400 degree Celsius, dia akan evaporate, betul? Sebab dah takat didih dia dah lebih. Then dia akan masuk ikut setiap fraction dia ni based on the boiling point. Kita ada LPG, petroleum, naphthalene, kerosene, diesel, lubricating, oil, fuel oil and bitumen. Jadi kita tengok apa kegunaan setiap ni. So LPG ni stand for what? Tadi siapa cari LPG? LPG stand for what? Liquefied petroleum gas. Okay, liquefied petroleum gas. Cikgu ada satu soalan. Kenapa gas dekat rumah tu kita kena tukar dia dalam bentuk liquid? Kenapa kita kena jadikan dalam bentuk liquid? Kenapa tak boleh hantar ke rumah dalam keadaan gas? Actually dalam tabung gas kat rumah tu dalam bentuk liquid, betul tak? Kenapa kita tak boleh collect dalam bentuk gas? Bila kita petik baru dia akan tukar. It will evaporate. Okay. Okay. It easily evaporate and then dia akan hasilkan, dia perlukan more volume. Sebab gas, kalau ikutkan gas dengan liquid, gas lagi besar tau. Macam mana kamu nak kumpul gas yang banyak tu dalam satu bekas? So, pakar-pakar ni dia cuba untuk kompreskan that gas into liquid. Itu yang jadinya LPG, liquefied petroleum gas. Kita dah transform daripada gas into liquid. Okay, petroleum, naphthalene, kerosene, diesel. Okay, now describe the refining process of crude oil in the distillation tower. Okay, pertama, what is the first step? This crude oil heated around 400 degrees Celsius until it changes into vapor. Okay, satu step yang pertama. Okay, yang kedua, this vapor is then feed into the bottom of distillation tower. Okay, dia akan pergi dekat bawah sekali dulu. Bila dia dah heated, dah jadi vapor, dia akan masuk pada bahagian bawah sekali dalam tower ni. So, as the vapor rise up the fractionating column, the temperature drops. Okay, bila dia dekat bawah tadi kan, dia dah jadi vapor, dia kumpul dekat sini, dan lama-lama dia akan evaporate naik ke atas. Makin naik ke atas, the temperature makin lower. So, the vapor condense back into liquid. Okay, dia akan condense back into liquid and separated from the sides of the column. So, dia akan jadi dalam bentuk liquid. Dia bermula vaporize, dah lama dia akan condense balik in the form of liquid. Fraction with lower boiling point rise up. Okay, manakala fraction with high boiling point at the bottom. Okay, beginilah. Kalau soalan tanya macam mana refining process berlaku, so kamu ceritalah. First, kita masukkan crude oil and then crude oil ni kita heated until 400 degrees Celsius. And then the vapor akan pergi at the bottom of the tower. And then the vapor akan rise until at the top. So bila naik atas, the temperature become lower. Then lama-lama dia akan condense itu liquid. Okay, now kegunaan dia pula. Different fraction and their uses. So LPG tadi. Okay, bilangan karbon usually 1 until 4. Okay, boiling point dia sangat rendah, less than 40 degrees Celsius. Uses untuk fuel for cooking. Petrol, kita untuk car engine. Apa beza, siapa yang selalu teman parents dia isi minyak? Apa beza RON 96, RON 95, RON 97, V-Power, apa beza? Apa beza? Apa beza minyak-minyak yang ada tu? Bukan. Apa beza antara RON 95, RON 96 harga? Betul, selain harga tu memang betul Kimberly, harga tu dia makin tu makin lagi mahal. Selain daripada harga, apa yang membezakan? Kenapa yang mana mahal Kimberly? V-Power kan, betul. Okey, memang kalau yang macam V-Power semua tu dia lebih smooth, lebih mahal. Sebab apa? Apa membezakan? Apa kandungan yang beza dekat dalam tu? Apa yang beza? Okay, beza dia adalah kuantiti lead. Kuantiti plumbum dalam minyak tu. Contohlah kalau 95 dengan 97 kan. Lepas tu kalau yang V1 tu I think 99 kita panggil. So 95% ni adalah 95% carbon and then 5% lagi adalah lead. Kalau 97, 97 is carbon and 3 is lead. Kalau 99 carbon and 1% lead. So makin kurang lead yang ada maka makin bagus dan harga dia lebih mahal. Itulah beza dia. Kan dia tulis tu unleaded kan. So maksudnya 95% ni carbon, 5% je dia ada bubuh lead. Sama juga dengan 97, 99. So ini ilmu barulah untuk kamu. Apa beza tiga-tiga minyak tu. Ni untuk kereta sajalah, fokus untuk kereta dengan motor. Okay, sambung. Naphthalene. Naphthalene kita guna untuk petrochemicals industry. Okay, kerosene untuk engine, jet engine, cooking and heating. Diesel ni untuk lori kan, buses and trucks. And lubricating oil guna untuk lubricant, wax. Okay, fuel oil. Minyak bahan api untuk power station, for ship. And bitumen untuk buat jalan raya, make road survey. Maksudnya semua hasil daripada proses fractional distillation ni semua berguna. Tak ada yang terbuang dengan sia-sia. Okay, now sambung. Explain why the size and the mass of hydrocarbon molecule increases down the fraction. Okay, carbon atom, kenapa size dengan mass bila ke bawah dia makin besar, makin bertambah? Because carbon atom are connected in a chain. So actually carbon atom dia macam ni tau. Ni dia bersambung, berangkai-rangkai macam ni. Hence, as the number carbon atom increase, maka change dia akan jadi panjang. So kalau dia ada, contohlah kamu tengok ya. Okay, kalau cikgu ambil contoh petrol, 5 carbon. Ni petrol, so 5. Kalau cikgu ambil naphthalene, naphtha, ambil 11. 7 hingga 11 kan carbon. Okay, kita ambil 11. Makin panjang. So dia berangkai-rangkai, makin panjang. 3, 4, 5, 6, 7, 8, 9, 10, 11. Makin panjang. So bila makin panjang, number carbon atom dia bertambah. So dia punya mass dengan size dia also increase. Sebab kita tahu daripada atas ke bawah bilangan karbon dia bertambah. So what is the effect when the size increase? Okay, as the size hydrocarbon increase, pertama apa yang effect? Pertama, boiling point dia bertambah. Okay, volatile dia kurang, volatile dia decrease. Makin bawah makin susah nak meruap. Less flammable. Okay, dan high viscosity. Okay, cuba kamu tengok. Kalau kita ambil contohlah bitumen dengan LPG. Bitumen is jalan untuk buat jalan raya kan. Cuba kamu nyalakan api. Antara kamu bakar jalan raya dengan bakar dekat dapur, yang mana lagi cepat menyala? Adakah jalan raya yang ada bitumen ataupun LPG gas? Yang mana easy to produce flame? LPG ke bitumen? Yang mana lebih senang produce flame? LPG ke LPG? Very good, Kimberly. Bitumen ni kalau kamu bakar jalan dia lambat terbakar. So nak menunjukkan bahawa bila saiz dia bertambah, bilangan karbon dia bertambah, it's very difficult to produce flame. And last one is high viscosity. So nanti 4 ni cikgu akan tunjuk satu video lah YouTube. Okay, why do the smaller hydrocarbon have a greater demand? Kenapa hydrocarbon yang kecil, contohnya macam LPG, kenapa orang lebih suka nak? Sebab smaller hydrocarbon, contohnya LPG, easily than larger hydrocarbon, burn easily, lebih mudah terbakar. So lebih banyaklah kegunaan dia. Okay, how to meet the high demand for smaller? Okay, larger hydrocarbon are broken into smaller useful hydrocarbon by cracking process. Tengok ni. Mana-mana yang larger hydrocarbon yang tak banyak permintaan, dia akan melalui proses cracking supaya dia boleh dipecahkan menjadi small hydrocarbon. Sebab kita tahu kan, dia dah cakap tadi, dia kata kalau larger hydrocarbon ni permintaannya tak sebanyak yang smaller hydrocarbon macam LPG, petrol orang lebih perlu berbanding dengan bitumen, berbanding dengan fuel oil ni orang tak berapa nak. So apa yang dia boleh buat supaya tidak berlaku pembaziran, dia ambil yang large hydrocarbon tu, dia undergoes cracking process, so dia akan jadikan dia jadi smaller hydrocarbon. So look at this, what is the cracking process? Tadi kita dah belajar distillation process kan? Okay, now kita dah belajar fractional distillation process, now is cracking. Okay, cracking is the process of breaking large hydrocarbon into smaller useful molecule. So in this process, large hydrocarbon molecule are passed over a catalyst at a high temperature. Okay, take note, mesti ada catalyst and high temperature for cracking process. So as the temperature increase, molecule will move faster and vibrate more vigorously. So this movement will cause the CC bond breakdown and produce small hydrocarbon. So apa kita panggil condition supaya cracking proses berlaku? Pertama mesti guna catalyst and high temperature. So kita tengoklah, ni condition dia, baru dia cakap. Pertama high temperature, berapa high tu? 600 degree Celsius. And catalyst used is aluminium oxide and silicon 4 oxide. So soalan mungkin tanya, so please take note. Catalyst used in cracking process, aluminium oxide or silicon 4 oxide. N ya, bukan O, N. So both catalyst used at 600 degree Celsius. Okay, what are the product? Cracking product produce smaller alkane, and hydrogen. Okay, name the source of large molecules of cracking. Long chain hydrocarbon fraction from petroleum. Okay, tak apalah ni. Alright, give reason to explain why cracking is very important process. So, kenapa cracking ni perlu? Kita dah tahu dah, cracking ni dia akan pecahkan larger hydrocarbon into smaller hydrocarbon kan. So more petrol produce and then kita boleh supply. Okay, next, more molecule alkane which are important raw material in chemical industry make various useful. So banyak kegunaan. 3, hydrogen which is raw material in the Haber process in the manufacture of margarine, and hydrogen also used as fuel in rocket. So inilah kegunaan-kegunaan the product of cracking. More petrol boleh guna untuk vehicle, small molecule boleh guna untuk buat plastik, alkohol, alkane, and hydrogen boleh guna untuk Haber process and also fuel in rocket. Okay, beginilah proses cracking. Contohlah decane. Decane C10H22 dia boleh crack into hexane, C6 and juga butane C4. Okay, decane. So dia akan jadi inilah. So this one is hexane, ni hexane. And this one is butane. Alright. Sama juga yang ni. Hexane, dia akan crack boleh jadi butane and ethene. So these two lebih banyak kegunaan berbanding hexane yang panjang-panjang macam ni. Macam butane kita boleh guna untuk LPG. Alright, discuss the problem caused by the current usage. Apa masalah-masalah yang mungkin berlaku? Pertama, petroleum ni is non-renewable resources. Apa maksud non-renewable? Dah belajar masa lower form. What is non-renewable? Apa maksud non-renewable? Maksudnya dia akan apa? It will what? Non-renewable. What do you understand dengan perkataan non-renewable? Use, finish, no more. Betul. Finish. Bila dah habis guna, no more. Okay, maksudnya dia akan finish. Dia akan habis. So as the demand for oil supply from around the world increase, the petroleum reserve are depleted in the near future. Satu, dia adalah non-renewable. Gariskan. The development of the world industry require the use of fuel and raw material for the ongoing petrochemical industry. Petroleum used to make useful product, blah blah blah. The demand increase and cost petroleum deplete rapidly. So sebab terlampau banyak permintaan, maka lama-lama dia akan habislah. Okay, a large amount of petroleum being used as a fuel in transportation and industries. Okay, ini masalahnya. Contribute to pollution, gariskan, and also global warming problem. And that threaten the survival of living things. Dia juga memberi kesan kepada pollution, especially air pollution. Okay. Now, discuss the solution to reduce the usage. Okay, bagaimana, macam mana kita nak buat supaya kita boleh kurangkan penggunaan petroleum. So, we can reduce the demand for the chemical raw material. Kita guna 3R, reduce, reuse and recycle to the public. Maksudnya kalau plastik-plastik tu kalau boleh recycle, jangan buang. Lepas tu sebab tu sekarang kita dah ada recycle bag, betul. Kalau kamu pergi shopping, beli groceries, tak payah minta plastik dengan diorang, you bawa lah plastik recycle bag yang you beli dekat IKEA ke, dekat mana-mana ke, bawa yang besar-besar letak you all punya barang. So dah jimat menggunakan plastik. So we can develop the alternative fuels such as biodiesel, biogas and bioethanol. Kalau macam kereta, kita boleh pakai solar tak? Can we use solar untuk kereta? Ada kan? Malaysia belum lagi lah, tapi ada a few negara yang beberapa kereta dia guna solar panel. Kenapa kita tak guna solar panel? Walaupun kita tahu that solar panel pertama dia tak pollute environment, kedua dia tak akan habis. Why we don't use the solar panel dekat? Yes, very expensive, betul, mahal, sangat mahal. Tak mampu kita nak beli. Tapi cikgu tengok dekat, adalah beberapa rumah yang cikgu nampak, dia nak generate dia punya water heater, dia orang letak kat rumah kan. Mungkin rumah you all ada kot yang macam solar panel letak kat atas bumbung, so nanti dia connect dengan water heater. Tak payahlah pakai elektrik, pakai solar panel. Rumah siapa ada? Selalu orang kaya je ada tu. Rumah cikgu tak ada, pakai air sejuk. Okay, so this one is the fractional distillations of petroleum. Cikgu tunjuk video sikit bagaimana dianya berlaku. Nak buat eksperimen tak boleh. So cikgu ada video sahaja. Caranya begini ya. Nanti cikgu tunjuk video lah terus lagi senang nampak. Okey, video.
Words we take, and those different we're going to be testing for the present chain lengths will have different. In the setup here, we've got a tube with some of our crude oil mixture in it. In the top of that is a thermometer, which in this case goes up to 360 degrees. We're going to have to get this quite hot to vaporize some of the components of the crude oil. The vapor will pass down the tube, and as it cools on its way down the tube, it will begin to condense back into a liquid, and we can collect at the far end. We're going to collect what comes off over several different temperature ranges, and at the end of this, we will have a number of different fractions. So, we raise this up to warm, and with a heating flame, and I'm going to just gently heat the end first of all. I don't want to heat it too strongly to start with. We're going to start to warm this through until we begin to get some vapor coming off. Here we are, our mixture is, you can see it starting to bubble there. And as that starts to come off, hopefully we'll be able to see the temperature at which that first vapor really starts to separate from the mixture. Okay, we can now see that mixture is starting to bubble away, and you can see some vapor coming off the top of the liquid. Can't guess this to zoom properly. Never mind. No, you're not behaving yourself. We have vapor coming off, and if we look at the thermometer, if we look at the liquid that's coming off, you can now see the vapor has been passing down the tube, cooling to a liquid, and coming out at the other end. We now have some liquid collecting. The current temperature of the vapor is between 70 and 80 degrees Celsius.
Okey, cikgu sambung lama sangat. Kita tengok hasil dia kejap Okey, ini tengok after beberapa minit.
And we're next going to take a look at their properties. Here are the 6 fractions we collected from our fractional distillation of crude oil mixture earlier on. We're going to have a look at some of the trends in properties.
Okay, kalau kamu tengok dekat video ni, dia ada different temperature. So the first one is 60 to 80, 80 to 100, 100 to 200, 200 to 60 and sampai 300 to 330. So first, apa yang kamu nampak perbezaan daripada color dia? Macam mana change color dia? For the first and the second test tube, warna dia adalah colorless kan? Betul. Lama-lama daripada light yellow until yellow. So kamu nampak warna dia bertambah daripada colorless to yellow. Okay, continue.
First thing we can see from this is color. There is a change in color as we go up in boiling point. We start off with the low temperature ones being almost colorless, and what we collect at ever increasing temperatures is more and more yellow. So there's a change in color, graduation in color. If we look at viscosity, in other words, how thick the liquid is,
Okay, now dia cerita pula pasal viscosity ataupun the thickness of the liquid. Sama ada dia likat atau tak likat. You know what is viscosity? Viscosity tahu tak? You know viscosity? Do you understand what is viscosity? Kalau kamu tak tahu viscosity, kamu tak faham. Pandai Imina. So kalau macam air biasa dia less viscous, betul? Sebab dia bila kita tuang senang mengalir. Tapi kalau macam contohlah kalau kita ambil jelly kot, kita letak jelly kan. So dia macam a little bit sticky. So susah macam honey, pandai. Honey tu dia more viscous than water. Pandai, very good. Bijak kamu ni. Tak payah terang banyak-banyak. Okay, tengok
What we
viscosity.
collect at low temperature is quite thin.
Thin. The first one is thin.
And as we work up to higher temperatures, it clings to the glass a little more. It goes up in viscosity. It is thicker. If we look at the other end, this is now more like a light oil. And we only collect it over a certain temperature range. Over an even wider range, we can go right up to, from real oil, bitumen, which is the thick black.
Okay, kita sambung. Viscosity. Okay, now kita nak tengok dia punya flammability.
And that is flammability.
Flammability.
Time now to look at flammability of the different fractions that we've collected. If I put a small sample of each, not much, we don't need much. A few more drops on that. Okay. Now to compare flammability, we're simply going to try to set light to them with a lid splint. And look at what happens. How easily they catch fire, and also how cleanly they burn. Let's try the lowest boiling point fraction first. There, that's set light very easily. The vapour caught before I got even close to it. Okay. That burn, this second one burns a little less fiercely. Slightly smokier looking flame. This one. Again, took a little longer to catch light. That one took a little more encouragement to catch fire. Not burning as fiercely. Not catching fire as easily, that one. And this one. Okay, it caught fire eventually. But nowhere near as fierce. And a much smokier flame coming off this one. I don't know if that's coming over on the camera, but much dirt.
Okay, so kalau kamu tengok eksperimen daripada left to the right, yang paling left sekali it easy to catch light kan. Dia senang senang mudah terbakar. It's flammable compared to at the right side ni. Satu lagi kamu tengok dalam dia punya dish ni, yang mana hasilkan lot of soot? Yang sebelah kanan ke yang sebelah kiri? Your left ke your right side? Yang mana produce more soot? Yang mana akan hasilkan soot? Soot ni jelaga ni, belah kanan. Kamu tengok the first one no soot. Tapi yang start dekat 3, 4 ni dia banyak soot. Soot ni produce from what? Datang daripada mana ni soot ni warna hitam ni? Datang dari Dari apa? Macam mana boleh jadi hitam? Carbon. Pandai Angie. Very good. So now hampir tamatlah kita. Okay, tengok ni. Alright, look at this. Okay, kita pertama kita tengok warna. So kalau tengok tadi 30 to 80 color dia adalah colorless. So tulis colorless. 80 to 120 also colorless. And then the third one to 120 to 160 light yellow. And then the fourth fraction is yellow. Okay, viscosity. Kelikatan dia. Viscous. Yang ni viscosity dia lower. Tulis dia lower. This one also lower. This one higher. Highest. Okay, sootness. Okay, sootness. No soot. The first one is no soot. Okay, less soot. More soot. And this one have more soot. Betul kan? More moss. Betul tak? Kalau salah betul kan? Betul kan? More moss. Angie betul kan? More moss. Alright. So kita tahu dah when going down the fraction daripada 1 until 4, contoh yang ni, color become yellow. Viscosity increase. Soot also increase. Cuma flammable je. Flammability dia je yang akan decrease. Makin bawah makin susah nak terbakar. Alright, settle untuk hari ini.